I'm just trying to come up with a toolbox of BMPs that are site-specific that the farmers can use to put on their property. 3 projects here at SIU. One of them is the first phase of the WASCoB project, which is water and sediment control basins. And it was more to look at water quality. It's in the name, water and sediment control. So we're looking at hydrology and sediment historically, but now we're trying to expand into looking at legacy phosphorus, looking at some land use characteristics, and then the WASCoB age to see if that played any role in sediment accumulation or phosphorus. The second project is WASCoB 2 is what we call it, or phase 2, and that's where we go into looking at different treatments. And those 2 projects are leading into kind of another project or interest we have. Again, looking at the denitrification potential and trying to figure out what the exact ratio of what we need to put in these WASCoBs is to get them to hold that nitrogen. So we're trying to do our best to come up with the right strategy, right WASCoB size dimension, and we may have to put more of them along the channel in some of these steeper areas. So that's kind of what we're seeing with that project. So we've got the 2 WASCoB projects. WASCoB 1, we have a master's student on, Durga Kendall, and she drives around and looks at 32 different WASCoBs across the 3-county area. And she's been the one working on the water quality and finding those nutrient reductions. And that's the type of data that we want to feed to the nutrient loss reduction strategy to try to figure out, how effective are these. And then the second project is led by Kendi. He's a PhD student, so he's answering the objectives that NREC has, but then he's going out on like a few of these side studies. Like I mentioned, what's the longevity of the biochar and the sawdust, and then the gypsum, like how often do we have to replenish it? I think the WASCoB stuff is important and trying to tweak them to get the right design, but I think a lot of the direction we need to go, especially down here in Southern Illinois, is this concentrated flow path issue, the CFPs, because all of our surface water is drained through just a few spots in the field. 82 to 100% of the water is coming through 1, 2, 3 channels in a field. So we need to really focus on those. We can spend thousands of dollars on putting riparian buffers in, but if we have a CFP through it, it's really not functioning for overland flow. It does, attenuate nutrients in groundwater. And then the third project is the stream bank stabilization project, looking at what the contribution of sediment and phosphorus is from the stream banks and seeing if it's agriculture or streams. We're comparing our data that we take from stream water quality and with the Illinois State Water Survey's data, and we're seeing that there's about 33% of the sediment is coming from the stream channel and only about 5% of the phosphorus. The one kind of drawback to that is the riparian forests are the ones that are performing the best, and then those reaches that are ag, that are farmed right up to the stream, are the bigger contributors of the sediment and phosphorus. So with that project, in the future, what we want to do is try to address, what can we do in the riparian zone, that immediate area right adjacent to the stream. So the stream bank project's in its final year coming up. So we've had 2 graduate students, 2 master's students work on that research. And over the time, we've done cross-sectional surveys where they go back over time and look at cross-sections. And then some of these erosion pins, which is the rebar that we drive in, has a washer on the top of it. It's pressed firmly against the bank, and then when that stream erodes, we can measure the distance from the washer over to the new bank and get estimates of not only stream bank erosion, but with the cross-sectional surveys, we can look at in-stream erosion as well. So what legacy sediments are being redistributed within the channel. So one of the things we found with that, obviously there's some erosion that is coming from the stream bank. Like I said, 33% of it is originating from stream banks, and then the phosphorus is a lot less than that. But moving forward with that, I think we need to focus on, again, riparian areas in terms of putting in grasses,